You see here bounded theorem. If f is Riemann integrable on the closed interval AB, then f is bounded on the closed interval AB. Assume that the function f is Riemann integrable. Let f is unbounded function on the f is an unbounded function in the Riemann integral AB with integral L. There exists delta, the positive quantity, such that if P be any take partition of the closed interval AB with norm of P less than delta, then we have the Riemann sum of the function f corresponding partition P minus L is less than epsilon. The difference of the Darboux sum of the function f corresponding partition P and the L is less than 1. The Darboux sum of the function f corresponding partition P and this L by the triangle inequality. The difference of two sides is less than third in a triangle. So the subtraction is less than this quantity is less than 1. Similarly, this quantity is less than 1. You take the quantity to write, adding the quantity absolute of L throughout. We got the Darboux sum of the function f corresponding to partition P less than the quantity absolute of L plus 1. It is first assertion. Let Q be another partition. Q equal to the taken as subintervals I equal to 1 to n be a partition of the closed interval AB with the norm delta less than delta, with the norm of Q less than delta. Since f is not bounded, since absolute of f is not bounded on the closed interval AB, then there exists at least one subinterval. Then there exists at least one subinterval in this interval in Q, that is xi minus xi taken, on which absolute of f is not bounded. For if absolute of f is bounded, then each subinterval we get a value mi. So maximum of m1, m2, m3, mn we taken. We pick tags of Q that will provide a contradiction to 1. We pick tags for Q that will provide a contradiction to 1. Let we take Q by Ti, that is xi, for I is not equal to k. Different I is not equal to k. And pick Tk is a point in the interval x k minus 1 xk such that f of tk minus 1 is greater than absolute of L plus 1 plus this quantity summation I other than k f of ti xi minus 1. This is the area of the tag, which all the tags their summation, the area, the total area by the triangle inequality absolute of a plus b is less than absolute of a plus absolute of b. The Darboux sum of the function f corresponding to the partition Q is greater than the area, the particular area, minus the particular area where k is not there. Okay, so this value must be greater than absolute of L plus 1. But here we have shown the Darboux sum of the function f corresponding to partition P is less than absolute of L plus 1. So there is a contradiction. Hence my statement is, if f is in Riemann sum, if f is Riemann integrable on the closed interval AB, then f is bounded on the closed interval